And I'd like to welcome our first speaker now, who is Enrico from the UCL Marine Research Group.
Thanks, Sophie. So I'll try to share my screen.
Yeah, perfect. We can see it.
Perfect. Great. Thanks. So for this series of artificial intelligence ABCs, what I'll start with this first presentation is looking at automation, so the letter A, and in particular focusing on applications for engineering, which is where my background is. So we'll start by looking at the status quo of AI, in my personal opinion. We then look at a practical engineering challenge I've been involved with over the past year in collaboration with the National Oceanography Center in Southampton. And then we'll make some conclusions on lessons learned and where I think artificial intelligence can grow into engineering in the future. So as you probably all heard, I guess that's why you're into this meeting. Artificial intelligence has grown in importance over the past decade, and we can really see topics like machine learning have gathered quite a lot of interest. And this is reflected here in the number of scientific publications. But this is not just about talk or scientific publications. There's actually proper technology being developed with a growth of 29% between 2015 and 2019 in European patent applications for machine learning. And this is reflected by an exponential growth in investments in AI and in a very big range of fields. So we have engineering, but we also have the healthcare sector, IT, we have security, we got estates. However, just to make the final discussion a bit more interesting and looking at a bit of controversy, is artificial intelligence actually delivering? Because some people say that this is what us, AI researchers or companies want you to look at AI as, so basically everything working really well. Whereas in reality, behind the scenes, we know that we are dealing with a few problems. So there's a lack of transparency. It's very difficult to interpret what is going wrong, what is going really well. It's difficult to interpret the results and what we're getting, the results we're getting. And then there's also a problem with generalizing outside of the training data ranges. So these are definitely challenges we have. And that's the reason why we're lacking still proper verification and assurance functions for AI right now, just because it's such a new topic. And then on top of this, we got a problem with exponential growth in cost. So this is a logarithmic scale. And we can see the computational cost of AI applications. And we could see that from the 60s to the 2010s, they were growing exponentially according to Moore's law. But more recently, as they really exploded in capability, the computational cost has greatly increased too, and actually it's exceeding Moore's law, and so what computer chips can do. And so that's why we had to go to parallelization and other sort of technologies just to counteract this weight. And the final thing to think about is also the financial aspects, so not just computational costs, which is part of the aspect, but it's also whether it's actually creating revenues. And so this is from the MIT Sloan Business School. It's a study from 2019, and it asked a big number of companies in the United States of whether AI projects actually added revenue to their company operations. And the most innovative startups and IT companies did end up with revenue creation in 50% of the cases. However, more traditional companies had only 26% increase in revenue with AI. The remainder was actually a loss or no gain at all. So we can see we have a bit of a mixed picture. And what I'm going to do now after this introduction is actually starting to look at a practical problem where I applied both conventional methods versus artificial intelligence to solve a practical engineering challenge, so that we can see what my sort of lessons learned were. So in this case, the application is underwater gliders. These are a type of autonomous underwater vehicle. They operate with a very simple propulsion system based on buoyancy. And so what this means is they can be operated for months at a time with a single charge. So they can stay at sea globally anywhere on the ocean for up to 12 months to study the ocean, explore the oceans, or even monitor regions if you're looking at a defense application, but what I'm focusing on is the scientific application, and in particular, the fleet of the Oceanography Centre in the UK. And one of the challenges they were facing was to develop an autonomous anomaly detection system. So why do we need it? At the moment, we have a large fleet of 35 plus, actually now 40 gliders operated anywhere on the planet. And there are only a few pilots that basically can access them through satellite connections and the cloud. So what happens is whenever the vehicle is on the surface, by satellite, it sends decimated data to the pilot. The pilot can check whether the scientific data is being stored on the glider so that the scientist is happy, because the scientist is the ultimate user of this application. And then it can also monitor the vehicle to see if there are any anomalies, because over such a long period of time, unfortunately, engineering systems will fail. And if everything is going well, then it can give a new command to do a new task or go to a new waypoint. Now, the challenge is basically trying to automate this, because at the moment, dealing with such a large fleet of vehicles with many different types of gliders that have many different failure modes just makes round-the-clock operations impossible for pilots, especially at night. They're not going to check the vehicles all the time. So we want to automate this whole system, because right now, over the past 5 years, there were a number of gliders that had failures that even expert pilots couldn't detect until it was too late. And what does too late mean in terms of these vehicles? Well, the problem is, if you develop a fault and you're not able to detect it in time, A, you cannot modify your mission to try to complete the mission with the limited capability. So you're asking too much of your system, which will just make it fail sooner. And B, it means that if you're in the middle of the ocean and you haven't gone closer to shore, it's impossible to recover the vehicle. So you just lose everything and a lot of money with that. What we're going to look at now is not so much in the decision steps, which is the next stage, but we're just trying to detect, can we detect anomalies before the human pilots can, just by looking at the data. So this sounds like a perfect machine learning problem. So we're looking at a sort of data analysis. We have a lot of deployments from the past. We looked at a small subset for this case of about 8 million sample points. And in particular, we wanted to look at healthy baseline glider conditions and also adverse behavior, such as vehicles losing wings after collision with ships, looking at biofouling, so small creatures growing on the vehicles, because this can actually cause the vehicles to become too heavy and then not be able to surface again. And finally, also looking at large appendages, because scientists love to put sensors on these vehicles, and we want to avoid having false positives in the data set. So the approaches we looked at range from the classical methods to the fully autonomous artificial intelligence machine learning solutions. So rule-based systems and model-based systems are simpler, and these are basically based on the designer observation of the system. So it's a human studying the problem and coming up with a solution. The rule-based method comes up with basically bespoke heuristics. For instance, for the glider, you can see that there is going to be a change in the orientation after you lose a wing between when you go down and when you come up. And so you can look at the difference in the roll angle and check if it's bigger than a certain threshold, you know you got a failure, otherwise you have no failure. So it is a really fast system. However, it takes ages to design and a lot of expertise, and so very costly. And this is specific to a single fault for a single vehicle. Dynamic models are better because gliders are similar vehicles. So even if you have different variants, you can actually have the same dynamic model for them in most cases. And here we're trying to track the difference between the model and the system response to see if we have an anomaly. If there is no anomaly, basically the model is expected to have the same value as the actual data. If there is an anomaly, it will differ. So it's, again, a fast, robust, and simple method. It's suitable for new designs because we're putting our knowledge into designing the system, so we're able to identify different faults and what the different faults mean in terms of engineering design decisions, what maintenance action to do, or what mission change to make. However, again, we have this very time-consuming design. Machine learning is completely different. It's a general problem, so we can use the same method for a plane, we can use it for speech recognition, we can use it for the gliders. And here again, we're looking at the difference between the original signals that we have and the reconstructed signals. So what is a signal? It could be like the vertical velocity, the buoyancy, basic information on the system. And we sort of like want, in an unsupervised learning way, we want to like decrease the size of the signals to keep only the fundamental features so we can remove the noise. And then we want to reconstruct it again, because if the system is trained with healthy glider data, then the two should be identical, the reconstructed signal and the original signal. If there is an anomaly, it's going to be different. We also had more complex methods, but the concept is sort of like similar. However, this requires a very large training data of healthy baseline glider to learn from. So we have a massive cost of deployment, which makes it impossible to train on the vehicle, but we can do this offline. We can do it from the shore. And this allows us to have a system that is able to deal with a large fleet of vehicle offline, and then just on deployment, send the deployed solution onto the vehicles. And this scalability is also very interesting. So looking quickly at some results, here the curves we're going to look at are the yellow lines for the machine learning, the purple line for the model-based, and the green line for the rule-based. The first thing we can see, so these are vehicles with different types of failures. We have a vehicle that was misballasted, biofouling, so small creatures growing on the vehicle. We got what is known as a false positive. In this case, it's just a different type of vehicle. It's got a big turbulence sensor on board, and we don't want to detect an anomaly here. We just want to see whether we're able to transfer the learning. And finally, we have a sudden type of failure, the vehicle losing a wing after a collision with a ship. And what we can see is that we have a low anomaly score for healthy condition, which is good. But then as soon as there is the detachment of the wing, the system is actually able to detect it as a sudden jump. So we're able to detect this anomaly. Then, if we look at biofouling, we're also able to detect slowly occurring anomalies, which is really good. What is even better is that we're not throwing an error for gliders with large appendages. So we're not doing false positives either. So machine learning is working really well so far. Unfortunately, it's not able to detect the angle of list, so the misballasting, which is actually should be detected. So we developed a more complex system, still machine learning, that was able to do that. The final thing to notice in this plot is probably looking at the model-based and the rule-based methods, so the conventional methods. We're looking at the green line for the rules-based method. We can see that the rule-based method is able to detect the loss of the wing very easily, but then we can't see it anywhere else. And similarly for the model-based solution, we can see it here, we can see it here, we can see it here. So it's very efficient where I designed it specifically for that problem, but it doesn't apply in any other case because I should have spent more time just to develop it for every single system. And development time took me a month just for the rule-based system and 2 months for the model-based system. So you can see how this quickly explodes in complexity as you have more vehicle variants and more failure types. So what are some positive lessons learned from this? Well, machine learning definitely has got better generality. We're able to learn from a type of glider, and we're able to transfer this knowledge to a different type of glider, so the one with a bigger sensor, without making mistakes, which is really good. It's got scalability. We can use the system on multiple devices very easily and have it distributed in an efficient way. And this is more important, for instance, for like, say, other engineering applications like the control of wind turbines. However, it's got a high training cost. We need a large data set, so we got worse sample efficiency, and it's very slow at learning. However, when we deploy it, we can deploy it in real time, so we can actually have a physical, practical system. But then, how can we interpret the results? Like in the previous plot, I could determine there were different anomalies. But what do those anomalies tell me? Like, what type of failures am I looking at? How can I update my maintenance or my mission planning? So there are some advantages and disadvantages. And in conclusions for this very specific small problem, it's clear that obviously there is a potential in machine learning to revolutionize the operations of these gliders, thanks to this ability to generalize the learning to different platforms and to scale to many vehicles. However, from an engineering perspective, where we want to design new designs, new gliders, it's very challenging because we need a massive data set to start with. But if we don't have a system, how do we get the data? And we have poor interpretability of the results. So for this particular application, how can I go from anomaly detection to fault diagnostics, even before decision making, if I don't exactly know what is wrong with the system? So the implications is that machine learning will work well, but we need to think of a few solutions, such as transfer the learning from simulations and experiments that we can do during the development of a new glider, and then adapt that to the full system and do further validation studies as we go along. And then we can also have hybrid methods where we include these dynamic models to create virtual sensors to give us some ability to interpret the results in a more efficient way, and at the same time improve the learning time. And with us, of course, at the stage we're still looking at human designers, but obviously in the future, it's going to be fully autonomous systems that will deal with the mission planning for these systems. So these are some of the references I've used in these presentations. I'll answer the questions at the end. I hope I've given you some thoughts, and I hope the other presentations will be in different fields so you have a big exposure.
That was excellent. Thank you, Enrico. And yeah, I'm sure there are going to be lots of questions. So for those of you who may have joined the meeting a little bit late, just to remind you that the Pigeonhole link is in the chat. Please follow that. You can see questions that have already been posted, and you can ask your own questions. And these will be guiding our panel discussion at the end of the 4 talks. So yeah, up next we have Daniel James. If you'd like to share your screen.
Yeah, thank you very much, Sophie. So good evening, everybody. I hope you're all having a good night. It's great to be here with you all, and I'd like to thank the Science Innovation Union for hosting this event. I'm just going to share my screen, so bear with me.
Yeah, that's great.
Great. So I'm Daniel, and I'm going to talk to you about my journey from predicting protein structures to structuring the world's knowledge at a company that I joined back in 2015 called AMPLYFI. And AMPLYFI help organizations carry out their own investigations using open source content on the web, but also internal content that resides in the company's databases, structured content and premium content. But the type of research that these organizations carry out often relies on carrying out lots of Google searches, reading lengthy academic papers, reports, news articles, and so on. So what we do at AMPLYFI is we use machines and we use machine learning algorithms to read the web at scale, all with the aim of uncovering insights to help organizations make better decisions. And we call it an insights automation platform. But before I go into detail about what we do at AMPLYFI, I'll give a bit of information about me. Enrico mentioned in his talk there, and I'm very, I have a lot of nostalgia for that UCL Portico background that he's got on his screen. But he mentioned, you know, what are the applications of AI, and you know, in companies. And my role at AMPLYFI is to lead product development. And so I am responsible for identifying opportunities to use machine learning and other techniques to provide utility to our customers. And I hope to share some of the features that we've built a bit later on. But my background is in biochemistry, and I specialized in protein folding, trying to predict the structure of proteins, the body's machinery, essentially, just using the genome sequence. Now, I've been very pleased to see the progress that has been made in this area recently with AlphaFold. But the question I often get asked is, how did I make the move from protein folding research to helping create an insights automation platform at AMPLYFI? Well, there are clear parallels with my work in protein folding and my work today. The first similarity is the rapid growth of biological sequence data and the growth of arguably the world's most comprehensive database, the internet. And both have been growing exponentially in the past. But the similarity doesn't just end at scale. Biological sequence data is also, as you know, many people on the call will know, very messy. And the techniques to record it often result in errors. The data storage methods used are often horrific, to put it modestly. And that brings me on to the internet. The internet is a store of a huge array of disparate data formats, and there are many contradictions and inconsistencies in the data when you're analyzing this content. So you've got the rapid growth in data, you have noise, but you also have another similarity between protein folding and internet analysis today, and that is evolution. So proteins and genes, as we know, evolve from common ancestors, and you can track their evolutionary history. They mutate, and those mutations that result in advantageous traits, or what we call phenotypes, would persist. And similarly on the internet, and in the world, ideas exist. They spread, sometimes virally, and they mutate and evolve over time, just as we can track evolutionary development of proteins and genes. We could do the same maybe with human ideas. So these similarities between protein folding and the internet fascinated me. And so I'm now really excited to be involved in creating the next generation of research at AMPLYFI. So what does our technology do? So we use machine learning models to scour the internet for documents at scale. We clean the documents that we find, so we remove the superfluous information like adverts and related links from the documents. And finally, we use natural language processing to extract key metadata from these documents. And we are currently analyzing up to 50 million documents each day. So that's news articles, it's academic papers, it's patents, it's blogs, and the list goes on, as you can imagine. So AMPLYFI can read documents just like a human does, but without the bias and at a far greater scale. And you can see a basic example of this on the screen now. So when our machine looks at a web page, and here's an example of a news article from the BBC, the algorithms highlight the topics, and these could be social, economic, political, technological topics. And they also identify companies and people in the text. So here is an example with one document. Imagine now doing that for tens of millions, hundreds of millions of documents. And that's what we do. But you might ask, well, you know, what do you use this for? It's cool that you can analyze this content, but what are the real world applications of this capability? So we're working with companies all around the world to support a wide range of use cases. Like Google, the use cases are industry agnostic. You know, what is the use case for reading and analyzing content? To give you a few examples of what our customers are doing with the capability that we've built. They carry out competitor monitoring. So what activities are my competitors involved in? They carry out company risk detection. So, you know, are there risks in my supply chain or with my customers that I could be made aware of? They carry out due diligence, of course. Can I identify nefarious activities about a particular customer or competitor? But we also have customers using our capability for strategic research. So technology horizon scanning. Which technologies are likely to disrupt my market in the next 50 years, let's say. And the list goes on. So what I'm going to do now is I'm going to bring this to life and give you a view of our product in action. So So the product enables you to type in a search query, and you can see here I'm typing in blockchain into the application. And instead of presenting a list of results to the user like you might get on Google, where you're going to need to read all of those results yourself, you'll see a snapshot of the results over time. And you'll also see topics that we've identified using an unsupervised learning algorithm. So you can see things like initial coin offerings, big data. You can see things like blockchain nodes and digital ledger being identified by the system here. And so our customers can use this to monitor particular trends in a space over time. Now, you can also start to track the development of these trends by different source types, so by patent or news or academic paper, which enables the user to start to track these over time. But you'll also see here that we're identifying organizations, people, and locations that are associated with my query. And when I click on those organizations, the machine can actually validate the entity that I'm looking at with a description and, with other information. And importantly, we're pulling in content from all over the world. So we're harvesting content from a number of different jurisdictions. And our machine learning models work in multiple languages. So some of the activities that our customers do on here will focus on research that's focusing on geographies or sectors or sentiment or risk, for example. But often we find that customers want to look at trends, what trends are happening in this space. And so when I click onto that tab, you start to see something that you may be familiar with from the likes of Gartner, the Gartner Magic Quadrant, where we can start to plot topics based on the year in which they've peaked. So you can see things like supply chain and Internet of Things there. But a number of our customers also want to be able to track particular companies and see which topics and activities they're associated with. And so you can see here that there is a heat map that is quantifying the strength of connection between key organizations and topics. And one of the things that you can do is create a portfolio of companies maybe you want to look at. So maybe I'm interested in banking, so I'm going to add some banks to my portfolio on the product. And I might be interested in some specific ones like HSBC. And what this will be able to do is it will be able to start to show me the associations of topics related to blockchain and these companies through reading all of those web pages. And so I can see here that there are connections to digital currencies, to smart contracts, to networks of computers. And one of the important things at AMPLYFI is that we can validate what we've done. So transparency is very important. So you can click into any of the visuals and be taken to the document that backs that connection up. Because of course, we're finding all of this from unstructured content on the web. So here is the reference to Goldman Sachs and Bitcoin, where they funded 50 million to an organization to handle consumer payments with Bitcoin. But you'll notice that the whole document has been analyzed for me, and I can click into any entity here, maybe Ripple, for example, and start to see, well, what can machine learning and open source data analysis tell me about these companies that maybe I couldn't find on a traditional database? Well, you can see we can identify basic information like, when was a company founded, where are they based, what industries are they involved in? But I can also see things like the funding rounds for a business, and this is all through text extraction. It's all through open source content. I can see what activities a company is involved in. So, Bitcoin, cryptocurrency in this case. And I can also look for things like adverse media. So you can see there's one reference here to fraud and Ripple. And I get taken to the sentence that is showing Ripple Labs and its top executives being accused of misleading investors by the SEC. So this is just giving you a view of some of the use cases that organizations use our product for at AMPLYFI. And we have a machine learning team in-house that is working on a lot of capability that we productize in this way. But one of the things that we do is we also work with a number of academic institutions to carry out research. And many of the research and development around our technology is under strict NDA. However, we are involved in a number of research initiatives that we are able to speak about publicly. And I'm now going to share some of those insights that we have uncovered working with Georgetown University and Harvard University. So the first case study I'm going to talk about is some work that we carried out with the Center for Securities and Emerging Technologies. And they are an influential Washington, DC think tank that sits within Georgetown University. And they were interested in identifying which companies were actively involved in artificial intelligence in China versus America. But they had a problem, and the problem was that company databases that you turn to traditionally, like Crunchbase and PitchBook, are limited. Yes, they have machine learning and NLP as classifiers, as the tags that they classify companies with, but they miss more granular descriptors. So they miss things like spatial learning and supervised learning and so on. So what we did is we used the product that I showed you earlier to generate a taxonomy of artificial intelligence terms through reading academic papers, news articles, and more. And you can see some of the terms generated on the right-hand side. And this model had to work, of course, in Chinese and in English to do this. So when we finalized this taxonomy, the system automatically then identified the connection between these topics and the companies. But we needed to build a model that went beyond simply finding proximity relationships, i.e. a company is mentioned in the same document as a topic, but actually to understand the meaning of the sentence. So is the company being described as an AI company, or is an AI term simply mentioned in the same sentence? And so the model was trained to differentiate between that. And as a result, we could classify a company's AI-ness, so how likely it is to be involved in artificial intelligence through reading the web. And you can see that we found many more companies through using this approach than the US databases PitchBook and Crunchbase, as well as the leading Chinese company database, which is Juicy IT. So this type of research has the potential to impact policy decision-making around the world. And another study that we carried out was looking at North Korea's biological weapons program with Harvard University. And what we did here is we used the AI platform to identify global topics associated with bioweapons research. And you can see topics like horizontal gene transfer and stem cell and viral vector being identified. And again, the system can identify where these topics peak based on the publication date of the documents. But when we built this picture of which trends were happening globally, we focused then specifically on North Korea. And the system was able to identify weak signals which could be used by governments to form policy around bioweapons and defense. So the tool identified around 170 institutions that were at risk of inadvertently aiding bioweapons development in DPRK. And this could be, for example, funding factory construction that could potentially be used to produce Bacillus anthracis and anthrax. But also producing fertilizers or training students from that particular university. It identified key research activities as well as upskilling and training of North Korean nationals in universities around the world. And these projects are very important to Amplify because we can use our capabilities to contribute to academic research and society as a whole. So we are currently carrying out some exciting initiatives with Cambridge University and Cardiff University. And we're always looking and open for collaborations with partners that meet certain criteria. Of course, we're interested in future financial benefits we're interested in stretching our machine learning engineers as much as possible. And you know, projects which have the opportunity to support societal goals. So hopefully you've learned a bit there about the applications of AI in the business world. I'm very happy to take any questions later on in the call, and thank you all very much for listening.
Thank you, Daniel. Yeah, really fascinating talk and very powerful technology. So next we're going to go to Andreas from Pundi X to hear about blockchain.
Hello, everyone. I'm Andreas and I work at a blockchain company called Pundi X. I'm glad to be here today and have this opportunity to discuss with you about blockchain technology. This is not going to be a technical discussion. I have a bachelor's degree in human biology myself, but I will do my best and simplify blockchain to you. So blockchain is redefining trust. Now you might be wondering how and why. So let's start by going a little bit back in time. So you might be wondering like who this guy is. So he is Luca Patrioli, and he was an Italian mathematician. He is also known as the father of accounting and bookkeeping. He is the one who introduced the ledgers in accounting systems, and Patrioli ledgers are used everywhere today. Now, as I mentioned, Patrioli ledgers are everywhere. Our whole financial system is a system composed of ledgers. Now, let's see an example of Bob trying to send money to Alice. Now, Bob has $100 bill. And so in order to send the money to Alice, he needs to go to his bank and deposit the $100. Now, the banker will not take the dollars and just walk to find Alice. What will happen is, through a series of entries into the ledgers, the $100 are transferred from Bob to Alice. Now, the most important question though is, which ledger do you really trust? Is it the Lehman Brothers or Wachovia? They went bankrupt. Or what about Washington Mutual? It was one of the largest United States bank failure. Now, let's go in 2008, where everything started. So in 2008, during the financial crisis, a mysterious person with the name Satoshi Nakamoto published the Bitcoin paper. Now, in this paper, Satoshi mentions that he will allow people to make online payments directly to each other without going through any financial institution, for example, banks, Visa, or MasterCard. And also, blockchain is the underlying technology behind Bitcoin, the well-known cryptocurrency. And so Bitcoin is built on blockchain technology. Now, what are the features of blockchain? Well, first of all, blockchain is decentralized. It means that any member can be part of a blockchain network. And this network is distributed across the globe. And each member has the exact same copy of distributed ledger. And this provides a complete transparency. Now, since the network is distributed, it means there is no, it ensures that the entire system will not break down upon a single point of failure. Also, any data, once it's on the blockchain, they cannot be changed or removed. Today, the authorized person who has access to the ledger, they can modify everything, but with blockchain, it cannot happen. Also, blockchain is peer-to-peer. What this means is that two parties or two persons can't interact with each other and make a transaction without the need of any intermediate in the middle. And blockchain is cross-border. What this means is that you can make a transaction, make a payment anytime and anywhere in the world, and nobody can stop this transaction. So blockchain removes the need of trust. Blockchain is a trusted ledger itself. Now, let's give an example and compare the difference of a traditional bank transfer today and a blockchain transfer. So today, you need to trust your bank to transfer your money. So if you want to send money to your friends in another country, then through a series of ledger, your money will be transferred. But when you make this transaction, you can hear your bank, they will say, okay, this might take 2 to 5 business days. And this is the reason, because it needs to pass into many ledgers. And if you are sending money to another country, for example, you need to send euros to UK, so it will convert from euros to pounds. So there will be conversion fees as well. And if your bank has a problem like a network issue or something, then you can never make this payment until it's fixed. Now, let's see a blockchain transfer. You can directly send money to your friend using Bitcoin, for example, and it will be faster because it's a direct peer-to-peer transaction. There is no conversion fees because Bitcoin is a universal currency, and the network is always online. It will never go offline. Now, since I spoke about the blockchain payment, and this is what we do. So at Pundi, we developed the world first point of sale device called XPOS. Now, XPOS so far is in more than 30 countries around the world, and it allows merchants to accept payments in cryptocurrencies like Bitcoin, Ethereum, and also it allows them to sell these cryptocurrencies to their customers. But blockchain is not only about financial transaction. There are other cases that blockchain can be used. We can take as an example blockchain for degree certification. So today, universities can issue their degree of a student on the blockchain. And what happens is they can issue the certificate with all the data they want on the certificate, and this certificate will be timestamped. It means that the time and the date will show. Now, the universities can all participate in this network, and at the same time, they will receive a copy of this record. And once it's approved, then it's on the blockchain. And let's say you want to apply for a job, and the company, in order, can now make sure that you actually own this degree by simply scanning a QR code, and it will show the transaction on the blockchain that is issued by the university. So no one anymore can fake certificate and apply at any jobs or master degrees or PhD. Now, for those who don't remember what this is, it's the long time no see airports. And last week, I saw this news. So Singapore government, they will start using blockchain technology to verify COVID-19 test results. So the passengers who have the test results of COVID-19, these results will be on the blockchain. So at the airport, they can check and verify that actually this paper is from the hospital, that this patient is COVID-19 negative. Otherwise, there have been issues, especially in France. It was on the news that people fake paper with COVID-19 test results. So blockchain can be used to prevent this. Also at Pundi, we developed our own blockchain called FunctionX. So FunctionX, it will allow any company to integrate our blockchain infrastructure in their company. They can make their own blockchain without any coding skills required. And also the main part of our blockchain is cross-communication, which it means it will allow different blockchains to communicate with each other. So in blockchain we trust, so if anyone is interested in joining us, let us know, and I can take any questions at the end. Thank you very much.
Thank you, Andreas. That was, yeah, a really interesting talk as well. And I can see there are already quite a few questions coming up on Pigeonhole. So it looks like we're going to have a really great panel discussion. Just to remind everyone, yeah, please do post any of your questions there. You can post anonymously. You can also upvote particular questions or topics that you would like us to discuss. So yeah, please go and have a look. And now I would like to welcome our final speaker of the evening, which is Marco Fernandez.
Thank you so much, Sophie. This is Marco Fernandez. I'm the CEO of Quantum Sense. We provide a precise, instant, and effortless search and processing, especially for banking and insurance. But similar to AMPLYFI, it's domain industry agnostic. This all started actually in my thesis at Oxford University, where I wrote my thesis in the field that was pioneered by Oxford on what they call quantum linguistics, where back in the day, this was all just theoretical work. There were no real quantum computers around. This has been about 8-9 years ago. And then about 3 to 4 years ago, I was contacted by a program from Canada, thanks to my supervisor in Oxford, that allowed us to actually connect with the first companies that actually launched quantum computers, the first being the one in Canada, others from California and all over the world. That actually allowed us to implement the framework from our thesis, that actually invested in us, that teamed us up, that really liked our idea, teamed us up with people from the business side. And the reason why I go into details is because this might be interesting for all of you as well. This CDL incubator from Canada, incubator and accelerator, actually just expanded to Oxford as well about 2 years ago. And they're always open for new ideas, for new ideas in the AI field, in classical fields, in quantum machine learning, as this one, and in many, many more space exploration and so forth. The problem we're trying to solve with our company is that of unstructured data. The real gold mine on the one hand, and on the other hand, Google is saying that about 80% of data is unstructured, and only about 1 to 2% are actually being harnessed nowadays. Why? It's a field that is very error and fraud prone. Think of it, for instance, in insurance. A lot of fraud is occurring. It's a very time consuming process because a lot of the data extraction is still being done manually. Not many tools applied for unstructured data. What we've done in order to overcome this quantum sense is we first built a classical solutions where quantum computers were still at an early stage, very few qubits around, which is a cloud solution that is a machine learning powered semantic search. Actually, at the time, the top in terms of accuracy and recall. It's a semantic search and processing. Let me give you an example, for instance, for insurance. If you look at the graph below, if you as a patient, as a client, submit your insurance claim, depending on which country you're in, to your insurance provider, it then runs through our what is called DISCO analysis, as it was the first framework that is both distributed and compositional, DISCO. It encodes your report, which can be a full letter, not just a form where you fill in individual words. Encodes it into vectors in this case. We've done the same for the database of claims that were submitted in the past to the insurances digitally. And then our semantic search actually allows to match them. It's a search that works on the sentence level, almost like your human brain when you think about it. It allows to compare two sentences, how close in meaning they are, which in this case for your insurance claim means it can match it to all the claims in the past that are very similar to yours. For instance, same health issues, same medication, same pricing, same geography, and so forth. And instead of a senior medical doctor at the insurance or an insurance agent having to spend on average about half an hour to 1 hour going through checking whether this medication is prescribed correctly, whether it's not fraud, all these parameters that take them 45 minutes on average. The matching with the database allows to see whether in the past 95% of the claims were actually approved by the medical doctor or not. If so, we automatically approve. So your claim will be paid out within minutes. Similar, you may have heard of Lemonade in the US for for insurance, for housing insurance, where it goes through about 20 fraud checks within 2 minutes, and you actually get your money within 2 minutes instead of weeks or months in some countries. And this can not only be applied in insurance, as in this example, but similar to AMPLYFI, for instance, in fundamental analysis for banking, for instance, for blockchain, for cryptocurrency. It can be for contract analysis, for insurance claims, like I say in insurance. It could be also applied for sentiment analysis. Or what Google has done, maybe you've noticed that Google actually had a major improvement for about a year now for English. In genuine search, they included their BERT model into the actual Google search, which is the biggest improvement in the history of Google search, about 10% for longer, for complex searches, for longer defense. Similar in AI assistants, as you know, Alexa and so forth, or for social media analysis. What this provides for our clients and then for their clients is a consistent and accurate language agnostic also, as we've seen in the company before, and format agnostic approach, which in turn allows to redeploy the workforce. My friend in the US, she didn't get the attention, she didn't get the payout from her insurance because our medical doctor said that he's just too busy doing the paperwork. He has so many clients at the same time. And then a solution like this actually allows people to focus on their actual occupation, what helps us people the most. It reduces costs, increases efficiency, and prevents errors, which then can be passed on to the client, of course, in terms of premium savings and so forth. It's real-time answers, and it's 24/7 availability. This is our classical solution that we implemented 3 years ago. We're about 3 years in now. And about a year ago, we took it to the next level. So we actually made the implementation on the first quantum computers, in this case on the IBM. And what this allows to do, instead of classical or deep learning, as you know, where you do NLP, you usually incorporate the meaning into a vector. This actually incorporates the meaning into a tensor of each word, which are intrinsic to quantum computers. And this allows to take into account much more of the semantics and the syntax, much more of the meaning and the structure of the language, which would then allow to overcome even the Google's BERT model in terms of recall. It allows a quadratic speed up, at least a quadratic speed up, multiple times faster, and an automatic data extraction. The milestones we've achieved since incorporation 3 years ago is that it works on the cloud. We have first clients. It works agnostic and at scale. We've now achieved the implementation on the quantum computer about a year ago. And what we're planning on doing, or what we are doing over the next 12 months, 18 months, is optimize it further for our existing insurance clients. We want to have a full enterprise solution in the market. We want to scale, of course, the number of clients, and then seemingly either initially, most likely extend it to a hybrid computer, as there is part missing, there is no pure RAM yet, and also as it makes sense in terms of computation to do some things classically, and potentially in the future on a full-scale quantum computer. Yeah, this is me. This is our teammates, the C-level, Sean from Canada as well, and our CTO, Swiss as well, from Daniel Weibel, who is really an expert in terms of architecture and scaling. Our partners, what we've initially started this at University of Oxford and in Cambridge. We use the SkipThought, recurrent neural network from the University of Toronto, expanded on that, on the accuracy, and then applied it to our use case. We retrained it on our documents on the insurance, the database of insurance claims. We have a couple of customers, some of them are listed here. We have some investors listed here, as well as some accelerators programs, which, as mentioned in the beginning, I think that it could be beneficial for everyone on the call. If you're not familiar with them, you can find the website online, or feel free to ask us any questions after the call or at the end of the call. This is it from my side.
Great, thank you, Marco. And yeah, a huge thank you to all of our speakers. That's 4 really excellent talks, and I can see that there has been a lot of questions. So we're looking forward to a really great panel discussion. So I'm going to pass over to Hia and Shan now, who are going to lead this.
Hi guys, thank you to all the speakers for your incredible talks. We've had loads of questions coming in, and to the participants again, if you have any more questions, keep putting them on Pigeonhole and upvoting the ones which are already on there and you might want answers to, so me and Sean can see them and go through them with our speakers. Okay, so I'll get started. This one's quite a general one, which has been upvoted the most. Our participants would like to know, how would you explain what AI or machine learning is to your grandmother? So it's an open question to.
You want me? Should I go first? Yeah.
Yeah, go for it.
Yeah, so I speak to my grandmother quite often. We haven't talked about artificial intelligence actually, but I think I'd probably say something like, you know, you can show a computer, and my grandmother is on Facebook, by the way, so she is kind of tech savvy, but we'd probably say, you know, you can show a computer lots of pictures of a person. We can train the computer to pick out that person from a bunch of photos. So I would probably reference, you know, the Facebook image tagging feature that she probably uses to give her an example of what AI is.
Awesome, thank you. Marco?
Yeah, I think Daniel summarized it really well. Just in case you want to have a look at YouTube, there's a funny video where they actually present this Google AI assistant to a grandma from Italy. Maybe you've seen it. It's called Hey Googie, something like this. You should be able to find it on YouTube. And maybe it's really funny how they interact, but it can be, maybe it's a good idea to come up with, show your grandparents an application of AI, right? And try with the interaction, try step by step. That's just like as kids, as we learned as children, it's almost the easiest way to learn when you actually interact with some applications of machine learning, of AI.
Thanks. Enrico, I saw that.
Yeah, no, it's actually, I think, yeah, Daniel and Marco covered this. Basically, if, yeah, my grandmother was Italian, so it was about cooking in that case. And I guess an example is that typically, normally when you're trying to do cooking, one way to do it is to follow a recipe, which is what a typical algorithm would do. The alternative with machine learning is just by copying you and seeing what you do, then it sort of like learns how to do it that way. So rather than following a sort of a script, it just sort of like try to learn from copying your behavior.
Great, thank you. Andreas, do you have something to add to that? Do you have something to add to that?
No, it's okay. They were well answered by the others. Yes.
All right, Sean, do you want to go next?
Yeah, I mean, it's actually good because we've got another question directly for you, Andreas. So there has been a lot of news recently about how much energy cryptocurrencies use and will probably use in the future. What can be done to make these technologies greener? Anything to say about that?
That's a really good question. So it's true that cryptocurrency consume energy, but it's what is keeping currently the network secured, because the miners behind on the blockchain, who are the ones who confirm the transactions and generate new blocks, are actually solving algorithms, and they get rewarded. So they consume energy. So basically, it's also what gives value to Bitcoin, because basically you use energy to produce Bitcoin, but at the same time we can see Ethereum, the largest, second largest cryptocurrency, they will move from proof of work that currently Bitcoin has and Ethereum has to proof of stake, which means that people can now lock their Ethereum and these transactions to continue. So it will make it like greener, about like 90% probably greener. Yes. So there are ways to solve this.
Okay, interesting.
Daniel, the next question is for you. So there's a question about how the NLP models are able to differentiate in subtleties of human language, such as metaphors or irony. How does your program differentiate or identify those, I guess, subtleties in the language?
Yeah, that's a really good question. Of course, you know, a lot of the capability that we've developed does produce false positives. And so a really important aspect when you're developing machine learning models that are going to be used commercially is to communicate the kind of limits of what ML models can do. And often we've found when we've done that with organizations, they can help us improve the models because we can often identify areas where we can make improvements. Now, with regards to subtleties in language, so things like sarcasm and metaphors, you can discern these subtleties, but there are always challenges in doing that. So we have a team of computational linguists whose full-time job is dedicated to refining our algorithms to ensure that subtleties in text, which can be profoundly important to the context of any document, are recognized. However, they're not perfect. Machines aren't going to be replacing human beings anytime soon. So one of the important aspects of our product is human judgment. You have to have a look at the evidence that is driving the insights that we produce. And generally, we never share an insight with a customer if it isn't coming from a number of different sources as well. So just like, we see a lot of misinformation and fake news out there today, the product, still requires the human to discern that information themselves.
Great, thanks. And that actually leads me to another question, and that's again for the whole panel. A couple of people have asked, do you agree that AI and machine learning is still in its learning phase rather than ready to take over? And how long do you think it would be where AI would be the go-to source, or will we ever reach that level of dependency on AI?
Let me maybe answer in terms of also the previous question. When it comes to sarcasm, when it just comes to identification, right, it can be done by sentiment analysis, by other algorithms. But when it comes to what you're saying for the future, when it comes to, for instance, humor generation, right, and the machine learning algorithm actually, or the AI actually be humorous, can it make jokes and so forth? This is one of the early stages, right? This is one. If you look at GPT-3, is now one of the first few frameworks that has a couple of examples which you can classify as humor. And I think, yeah, this is definitely one of the unresolved fields, one that will becoming in the next couple of coming years.
Awesome.
Thanks. Okay, so we've got a couple of questions for Enrico. Enrico, you worked on applications of AI in sort of wave energy conversion. Could you talk a little bit more generally about applications of AI in renewable energy in general? And you also threw a kind of spanner into the works and said, that there are these big questions that AI hasn't answered, including a lack of transparency. Could you talk a little bit about like ethical issues that might be arising from this?
Sure. So yeah, no, thanks for the question. So yes, my expertise, I sort of like go between offshore renewable energy and underwater vehicles. The reason why I decided to present underwater vehicles was because I find it from an AI perspective more challenging, because these systems are undersampled, so you don't have that much data, they're limited. With wave energy conversion or floating offshore wind turbines, tidal energy devices, or offshore renewables, I think the AI future is looking brighter. And the main reason for that is because the current technologies are working well for a single device, but now that to make it work from an economies of scale perspective, as the UK is now leading in offshore wind, for instance, then there's a problem with big data, like there's an explosion with data. And what we've seen is that actually having a centralized control for many devices where you take decisions for the whole farm produces more power per turbine or per converter than an individual converter just by itself. So by combining their actions and working cooperatively, you can actually increase production. So that's why the current technologies which come from the control system theory are limited, because as soon as you start to move to 16, 20, hundreds of turbines or converters, that's where basically these conventional technologies are not able to deal with those massive amounts of data. So in that regard, it's still early days. It's not properly accepted, if we have to say it, in the field. So actually, like these hybrid methods where you still include some dynamic modeling is the only way to actually get funding, if we have to put it honestly. But I think there's going to be, my hope is to have a vision where we will be able to use AI to deal with these big data problems. Concerning ethics, that's a very interesting question. And to be honest, that's one of the main topics of interest for engineering, on top of assuring the behavior, like getting the behavior you think you will get. In terms of ethics, like for instance, I'm dealing with ships. For ships, there are questions being asked, for instance, by the MIT Ocean Engineering Group, of what it should be in a channel. So for instance, if you go a channel and there's like a tanker that you see has lost the use of the rudder, should a cruise ship hit the tanker, or should it go smash into the side? So if you smash into the side, the risk is you lose more people. You would probably have a tragedy on the cruise ship, but at the same time you avoid a massive oil spill. And to be honest, this is very similar to what the automotive industry is dealing with. As far as I'm concerned, because I'm mostly dealing with applications, I think this problem will be solved first by the automotive industry, because there's a bigger push to get it done quickly. And those ethical questions need to be addressed, because it's the same as when you're trying to avoid a pedestrian or a car. So I'm sorry, I'm sort of like I'm sitting like in the back seat on this and waiting to see what the consensus will be.
Oh, it's really interesting. Hi.
So another question for the panel. I'm sure Andreas, Daniel, and Marco would definitely have some relation to this. In your own companies, how has COVID impacted the growth, or just your companies in general?
I can go first. So basically, we have a point of sale device that needs to be used inside the stores, inside the retail stores. And we know with COVID, like nearly all the shops shut down. So there was not a lot of usage, but for the stores who are open and for 1 year, because there are like fees when processing the transactions, we were giving back these fees to the merchants and help them out to move forward. Yes, but now things are getting back to normal, so yes, it's going better.
Thank you. Daniel?
Yeah, so the obvious impact to our business, of course, is remote working. In fact, we're all on this Zoom call now. So actually, we dealt with that quite well, because we acquired a company in the United States called Deep Web Technologies, and they operated remotely already. So they had 10 years experience of working from home. So they kind of shared all of the tips with us when we all had to start working from home. I think the big area that it's had an impact on the company is that, you know, COVID is similar to what we would kind of call a black swan event, as much as there were a lot of, predictions that this would happen. And so it has definitely made organizations and corporations more conscious of disruptions that could happen that we haven't been planning for. And so we have seen that it has expedited demand for our capability, because we're scanning the web for signals for disruptive events. So yeah, one of the things we actually did in February last year was produce an application called coronavirusgateway.com, and that's accessible today. You can go on to coronavirusgateway.com, and it scans the news across all modern languages for anything about COVID-19, so that this can support journalists and researchers to uncover information about the pandemic. So yeah.
That's really cool. Marco?
Similar for us. Luckily from our side, we were mostly working remotely beforehand. We have people in North America, South America, and Europe, so kind of had to work remotely. So that was simpler. But a lot of turbulence on the client side, of course, it has affected everyone. But like Daniel is saying, in terms of these our AI businesses, which are kind of helping people to digitize their companies, for many of us, it was actually beneficial as well in terms of client contacts and so forth.
Awesome, thank you.
Right, so we've got another, I guess it's kind of a fun question almost. So yeah, artificial general intelligence. When is it coming? When are the machines going to get us? This is open to anyone who wants to take a pop at it.
So I'm a huge fan of Westworld, and so I'm quite scared actually of the types of science fiction kind of predictions that could happen with artificial intelligence. I think we're a very long way off that capability. We're kind of 1% there, and there's 99.9999% left to go, I think, in this space. So I'm not concerned that that's something that's going to have an impact on us in the medium term, but it's definitely something that we should be cognizant of, particularly as well in parallel with the development of technologies in the robotic space. You know, we're starting to see the two worlds come together. So, but yeah, machines are still quite stupid.
Fair enough. Marco, perhaps did you want to add anything to that?
Sure, I agree. I mean, the researchers vary. They say between 2040 to in 100 years. I agree, it's still far off, but both strong AI as well as AGI. But it doesn't mean that narrow AI isn't super powerful, right? In terms of, for instance, computer vision, object detection, it has surpassed us in 2014 already, right? And in terms of scaling, how much you can reach, because it's all computational, how much you can do in some narrow fields, it already surpassed the human brain. So even if it's very far away, it's a strong methodology.
Thanks. Does anyone else on the panel want to maybe have a pop at that?
Yeah, no, I agree. I deal with like autonomous vehicles, but in reality they are automated. So automation right now works really well in the field, and it's been doing so for the past 20 years very efficiently. It's the autonomous decision making which is always limited to whatever the designer sort of constrain the problem to. But hopefully we'll get there.
Andreas, anything?
No, not by my side. Well, AI was a technology like from like many years ago, but now it's like we see it coming forward and it really keeps striking. And yes.
All right. Thank you. Thanks very much. Yeah, that was a fun question.
So now I have a question for Andreas and Daniel, and it's more related to how you guys got to your positions right now. As you both have a background in biology originally, so how did you navigate from being in biology into the field of AI?
Okay, so I was still in university when I was studying human biology, and then I also started reading about blockchain and Bitcoin, of course, and I realized like the need of blockchain and the need of blockchain payments. Then I was like started searching for companies who provide blockchain payments, and I stepped into Pundi, and then I decided to join the team while also studying biology. And in the years, I also saw that actually healthcare can be combined with blockchain as well. Yes.
Yeah, so from my perspective, I was studying biochemistry at UCL, and I was in a lecture, and the lecturer showed me a photo of them modeling a protein in the real world. So they actually had sticks and balls in the room showing the protein modeling taking place. And at this point, I hadn't really carried out much coding or programming myself. But I kind of realized we really do need to, given the growth of sequence data in biology and data in general, most research projects now require you to be able to carry out data analytics computationally, and that leads you into artificial intelligence and machine learning inevitably to try and solve those problems. So I taught myself a few programming languages, and I then moved into the field of bioinformatics. So, the meeting of biology and computing to solve these challenges. And then I saw that there was a company just starting in 2015 that was using artificial intelligence to analyze the web. And I started as a software engineer. So most of my work was, building capability. And over time, I've gradually moved into the product space. So how can we productize this capability?
Awesome. That's really interesting. Thank you.
Okay, we have a couple of questions here, I guess mostly to Andreas. People really want to be reassured if Bitcoin can be hacked or not. Can you give us any assurance that it's really a safe technology?
Okay, so I'm sure you saw many headlines like Bitcoin is hacked or whatever. Well, that is not true at all. Let me explain why. So when something new is coming, most of the time humans tend to follow things they did in the past. And so blockchain is decentralized, okay, which means that the whole network is distributed. So there is not any central point that someone can attack and take the network down. So if they attack at some space, the other space is still active, so they cannot take over the network. Now, the stories that you hear about Bitcoin getting hacked is because people tend to send their Bitcoins into centralized exchanges. So centralized where they have server and a normal website. So the hackers, what they do, they attack the exchange, that centralized exchange, and then they steal the Bitcoins. So actually, the answer is no, Bitcoin cannot be hacked at all.
Just a question from me on that. What would you recommend people do if they have cryptocurrency on one of those central exchanges like Coinbase? And this is a personal question.
Okay, so personally, what they need to do if they own Bitcoin or any other cryptocurrency, they need to use a private wallet. So what is a private wallet is you own the key to that wallet, only you, nobody else. But if you share this key with someone else, they also have access. which is some people fall into scams and they share this key with others and then they lose their money. Because with Bitcoin, you become your own bank. You have control over your money. You can send your money to anyone and nobody can stop you from doing that. So yes, is to store their crypto into private wallets that they only have access to it.
Thanks, sir.
Thanks, guys. Marco, there's a question for you. As you said in your presentation that when an insurance claim is being made, if, for example, it's the same disease, same medication, and that claim has been accepted 95% of the time, it goes through in minutes, right? What if a mistake has been repeated multiple times in the past? How can you avoid automatically repeating them or that happening again?
Of course, yeah, good question. Yeah, we have several other procedures for fraud detection. I can outline a few, and of course for the complex ones. For instance, when the 95% are not surpassed, right? When there's no agreement among the matches of the senior doctors that made the decision in the past, and we still pass it on to insurance agents, right? We don't want to take the wrong decision and so forth, and an insurance agent is needed to, or a medical doctor to protect that everything is fine.
All right, thanks.
Okay, yeah, there's a question here for everyone on the panel. What is an AI technology that you foresee having like a really big impact on people's lives in the future? It may, be something that you're yourself working on, but yeah, we'd like to get your thoughts on that. We could start maybe with Enrico.
So, well, having a big impact on people, I probably think one of my favorite technologies is reinforcement learning. So like getting systems, getting robots to learn by trial and error, or even by copying someone else, how to do tasks. And so I can really see that how this is going to be useful, for instance, for cars, when you're like trying to do like the automatic parking, maybe in a difficult garage. Could be applied, I don't know, in cooking robots. It could be applied in many, many fields.
Thanks. Perhaps I throw it to Daniel.
Yeah, so one of the areas that I think is going to only increase in prominence is predictive capabilities. So, at AMPLYFI, we do a very good job at structuring the world's data. So, we're trying to find insights from very noisy, disparate data sources. But what we're working on is making predictions using the insights that we have extracted into the future. And they could have multiple use cases, of course. So going from predicting the credit distress of a company or bankruptcy events down to predicting global pandemics, for example. But I do think actually it's always at the intersection of these different technologies where we're going to see the most impact happen. Blockchain is a space that I think is going to be massively impactful to society. So I see all of these spaces coming together.
Thanks. You might have stolen Andreas's comment, but yeah, if I just go to Andreas.
Yes, what Daniel said actually, all this technology at some point will meet. So AI is can be like used in the banks for all the financial things. But at some point, they would need to audit all the tasks that the AI did. So if they use blockchain, then this can provide transparency and they can go and backtrace and check everything that the AI has performed. And this can also make people maybe trust the AI more if there is a complete transparency of the decisions makings of the AI.
Okay, and finally, Marco.
Sorry, could you repeat the question?
Oh yeah, the question was just what technologies that are being developed in the AI field will have maybe the biggest impact that you foresee going forward?
Yeah, right. So our company was mostly focused on NLP, as you may have noticed. This means natural language processing, so mostly text-based, right? Now, over the last 1 year, we've also adjusted that you can actually do semantic search on images as well, meaning computer vision. Kind of like on Google search, right? You can also put a picture in now, and it will find you the similar pictures or the picture you're looking for. Always allowing that it will actually find pictures that have the same objects in the pictures in meaning, right? Not just in exact keyword match. And why do we add that? Because I do see a lot of future there. I think in terms of, at least in terms of business applications, I think computer vision may even be stronger at the moment still than NLP. Even though I really saw 2020 as a big leap for NLP. And for the future, of course, also reinforcement learning. GANs, of course, for synthetic data generation, which we, for instance, use for data augmentation. A lot of companies don't have enough data, right? You still need a big amount of data if you want to reach high accuracy with machine learning, and this is a strong technique both for computation as well as for NLP to raise the accuracies, or to actually enable AI for companies that just couldn't otherwise.
Oh, great. Thank you so much. I guess we are going to probably wrap up soon, but what we just wanted to maybe do is give each of you just a very small amount of time. Sorry, I probably should have planned this slightly better. To just maybe talk a little bit about your own personal stories and how you came to be in the fields that you're in, and any advice that you have for people who are starting out in the field and where they might want to go. Yeah, if we could start off with Andreas.
Sure thing. So as I mentioned previously, I was still doing my bachelor degree in human biology when I started looking into blockchain and read different articles about it. But back then, when I was reading about Bitcoin and these things, they were like, oh, they use it in the black market. There was really bad in the social media, like the way in the news they saw Bitcoin back then. And what really triggered me to switch to Bitcoin is I wanted really to send around, it was 50 euros to my brother. So I went into my bank app, and the network, I don't know, the network of the bank was down. So I couldn't really send those 50 euros. And then I was like, okay, but with Bitcoin, I can really do this. So I saw the revolution in Bitcoin, how it's really changing things. And we can see now big companies entering Bitcoin, like MicroStrategy and even Tesla. Around 2 weeks ago, they announced that they bought Bitcoins as well. And they will start accepting Bitcoin as a payment method for their cars. So it's a really interesting field. And I'm always open to any questions, to anyone who wants to learn more about it, or even, get Bitcoin or something. Yes. Thank you.
Thank you very much. If I just pass it to Enrico.
Sure. So my background, I did my Master of Engineering in Naval Architecture. So I was supposed to design ships. And then after that, I started to do a doctorate in offshore renewable energy. And I started with a project with a company in wave energy. Now, I don't want to scare anyone. It was a really exciting time, really enjoyed it. It was practical projects. I was working on hydrodynamics for this famous Scottish company, but then they went bankrupt. And in my case, it was an industrial doctorate, so I was saved during the administration by my university. And I found a new partner, which was Wave Energy Scotland, so a public body. And they decided that because they had this doctorate, I could do something very high risk. So they would fund low risk research, high TRL. They wanted to have some really high level TRL. So in my case, I was starting to look at this wave energy thing, and I was thinking that actually it's not viable right now. And one of the best ways to get the biggest gain in performance was with control systems. And I thought, what about looking at something completely different? What could AI do? Do we have advantages or not? And so we started building from that. And after my doctorate, mostly because of my experience with that bankruptcy, which taught me to be flexible, but then I decided not to risk it. And so I took a job as a research assistant at UCL, then I became a research fellow and then a senior research fellow. And so since 2017, I've been at UCL, and I've started to then do some research with the new group. And so it was going back to underwater vehicles. And I tried to sort of relate the old field to the new field, the new challenges, and so on. So now I'm actually still like following these two streams, which is a bit unconventional in academia, mostly because of my separate interest. So I think like it's possible to make it to academia. I think it's very challenging. You always need to bid for funding, and it can be very frustrating. But it could be interesting for people. Having said this, I think now that enough years have passed since the bankruptcy, I'll probably try my luck again in industry, but we'll see how it goes.
Right. Yeah. What about you, Daniel?
Yeah, so I think from my personal experience, and my advice would be to do as much as you can yourself. There's a lot of resources out there on the web, you know, YouTube tutorials. There's a lot of data that you can use to help you in learning capabilities like this. And generally, just ask people and reach out to people. I'm sure, you know, Andreas mentioned, you know, reaching out to him on LinkedIn. Everybody on the panel would probably be fine with people reaching out and asking questions. And I find that the people that we want to hire at AMPLYFI are the people that don't just expect us to do everything for them, that they have an ability to teach themselves capability using the knowledge that is out there. So yeah.
Thanks, Daniel. And yeah, just to round us off, Mark.
Sure, gladly. As I mentioned in the talk, maybe when it comes to starting your own business, I can actually really recommend an incubator. You learn a lot of the business skills. They teach you that you really need to find, if you want to have a successful business, a real pain point for out there for businesses. When it comes to more, how you can learn more about machine learning, deep learning, and so forth, as I used to teach for a while after my studies, I would highly recommend the courses by Andrew Ng, so meaning deep learning AI, meaning Coursera, as he pretty much has a specialization for pretty much any, for instance, those 4 fields that I saw as quite futuristic for the coming years that I mentioned before in the question before. He pretty much has a specialization for each one of them. He has one for in medicine, for instance, as well, and so forth. And you can audit them for free, or you can join them for cheap. And yeah, I love these courses. I can highly recommend besides what has been mentioned beforehand, YouTube tutorials. For quantum specifically, it's a bit harder to find. There's a couple of courses out there. Companies like IBM have tutorials that can be helpful, or with certain books, it's maybe a bit more researchy still. Maybe read the current papers, or try to study with the books. I would recommend.
Great, Marco. Yeah, thanks so much, and thanks to all the panel. I guess we can pass it back to Sophie now.
Amazing, thank you. And yeah, a huge thank you once again to all of our speakers, and also everyone at the SIU who has worked behind the scenes to help put this event together. So I just wanted to share this screen finally. Please don't hesitate to contact us. We have currently got job opportunities, so if anyone would like to come and join us at the SIU. I would also like to tell you that we do have another AI themed event coming up, this time focusing more on AI and health tech, and that will be at the beginning of April. So do follow us on social media, connect with us on LinkedIn, and you can keep up to date with everything that we've got going on. yeah, once again, a huge thank you to all the speakers that have given up their time for us this evening. And yeah, hope you all enjoyed the evening, and we'll see you again soon. Yeah, thank you and goodbye.
Thanks again. Bye-bye.
Thanks, everyone. Bye.
Bye-bye.
Thank you.